Good afternoon, grade 8s. I have to teach you perpendicular and intersecting lines or any line geometry. Tomorrow we're also doing line geometry, but specifically with parallel lines in mind. So remember, a line is basically 1,000 or so dots placed right next to one another, which then forms one straight line. And it should always, your straight line should always be drawn with a ruler. A transversal, specifically, this is a word you have to know before we move along to tomorrow's work, is that a transversal is a line that cuts through two or more parallel lines. Okay, so we'll talk more about that tomorrow. Firstly, adjacent angles, which would mean that the angles are placed right next to each other. They are neighbors, okay? And adjacent angles usually come from the same point, as I will illustrate to you as we move along. So this is what they're saying here. Adjacent angles have a common vertex and share a common arm. Okay, so there's, for this example, for A and B, which are an example of adjacent angles. And as you can see, they come from a common vertex. This would be the common vertex over here, and share a common arm over here. That's right between them, the same line between them that separate the angle. Okay, so A and B are examples of adjacent angles, neighbors. C and D are not adjacent angles because although they share a common arm, they do not come from the same vertex. They don't have a common vertex. See, D's vertex is over here, C's vertex is over there. Then E and F are not adjacent angles because they do share partial common arm, but once again, they don't come from the same vertex. And that's all there is to adjacent angles, but you should know. Complementary angles add up to 90 degrees. So that's the word we use when we want to indicate that two angles together gives you 90 degrees in total. So as you can see here, we've got the 20-degree angle and the 70-degree angle. They're not right next to each other, so they're just complementary angles to one another because together they give you 90 degrees. But now they say in your book, draw a pair of adjacent complementary angles. So I'm giving you a moment, actually pause, then try and draw a pair of adjacent complementary angles, meaning they come from the same vertex and they share a common arm. Okay, and then play again to see my drawing of this. Okay, and there you have it. So that would be an example of a pair of adjacent complementary angles. As we can see, it comes from the same vertex, and there's my common arm. So let's just write in a number of degrees here, 30 degrees and 60 degrees, and together it gives you 90 degrees, and that's why they're adjacent complementary angles. Adjacent, meaning next to one another, neighbors, and complementary because they add up to 90 degrees. Then we move on to supplementary angles, which means they add up to 180 degrees together. And this is what that would be. 85 degrees, 95 degrees is 180 degrees. Are these two angles adjacent supplementary angles in any way? Why or why not, you should ask yourself. So it isn't because they do not share a common vertex. Remember, adjacent angles share a common vertex. Okay, but now an example of adjacent angles being supplementary is adjacent angles on a straight line. Okay, so on a straight line, automatically we have 180 degrees. So if we put an arm, it creates two angles, and then they would automatically come from the same vertex, the point over here, B. And it creates two angles, B1 and B2. Now we can write this next as a statement, okay, as such. Either ABD, meaning from A, the point A, through to B, where the angle is created, and that's why it's got this little cuppy on it, through to D. And that's what creates the angle. See again, A, B, D. It forms the angle. Plus the angle DBC. So from D through to B, where the angle is created, that's why it's in the middle. Where the angle is created would always be written in the middle, through to C. So it forms the angle DBC. So it's just saying here in this statement that it adds up to 180 degrees. And then another way is if the angles are marked with a 1 and a 2 or something of the sorts, then we can write it as B1, as in that angle over there, at the point B where it's marked with a 1, and plus B2 at the point B where it's marked with a 2. And you'll see it's not written in big numbers, it's written as a subscript in a small letter next, and a small number, sorry, next to the alphabet letter. So together they add up to 180 degrees. That's what this says. So this would usually be your statement. Let me just write this in here for you. This would be called your statement. You're going to see we're going to work with a statement and a reason when we do problem solving with geometry. So this is your statement, and as you see here, we have abbreviated the reason. So we're saying the angles add up to 180 by saying B1 plus B2 is 180, okay? And then we provide a reason as to why we make this statement, and that is the reason over here. Adjacent angles, we abbreviate like that, on straight line, and that's it. So angles about a point is our next straight line geometry thing we're looking at. Angles about a point add up to 360 degrees, okay? And I think we all know that. It makes a full revolution when you look at the same point, and it's created by putting arms around it, created a few angles. So see that they're all adjacent as well, okay? Because they come from the same point, but B is adjacent to C, and C is adjacent to D, D is adjacent to E, E is adjacent to F, etc. Okay, but B is not adjacent to E, for example. Not that we can use it in here because we haven't been given any straight lines or complementary angles for that matter. Now, all you would do would be to say the statement A plus B plus C plus D plus E plus F. In other words, all the angles around the point is equal to 360. That would be your statement, okay, that you would make. And then the reason, as abbreviated over here, that's my reason, that goes with this would be angles about a point, abbreviated in such a manner. On to the last theory we have for today. When two straight lines intersect, the vertically opposite angles are usually the same size. Now, if you go and play around and you draw two lines which straight lines with your ruler that intersect, and you measure the angles opposite one another, you will find that they are the same size. A will measure the same size as C, and B will measure the same size as D. You will just see that it happens that way. And so we can make the statements, whichever one we need to use in a diagram, that A is equal to C's size and B is equal to D. So your statement would be this, either one of these, whichever one we have to work with in a problem. Okay, and then your reason is over here, vertically opposite angles. That's what they're called, okay? Not just opposite angles. You won't get the marks if you just say opposite angles. Vertically opposite angles indicate that it happens when they're opposite angles when two lines intersect one another. Okay. All right. So now we are going to look at two examples over here. The first one, you have to identify what are the variables. Now the variables will usually be given in lowercase letters. Okay. So A and B are the missing angles that we're looking to find the value of. A. And we have to find out what information can we gather from the given angle in relationship to any of the missing angles. And I have a relationship for each of these missing variable angles that I can relate the 48 degrees to. So firstly, A and 48 degrees, what relationship do you see? You might tell me already now. But I notice that they're, like in the diagram above, vertically opposite angles. A is vertically opposite to the 48 degree angle. So we can therefore say A is equal in size to that 48 degree angle. And the reason, as you can see above here, is vertically abbreviated like that, opposite angles. Okay, and now we move along. We've solved for A. We move along to B, and B is, if you look at this diagram, on a straight line next to the 48-degree angle. So it's adjacent to the 48-degree angle, and therefore we can say that together they're 180 degrees. So we can say B plus 48 degrees is equal to 180 degrees, and the reason being adjacent angles on straight line. Okay, and then, so that's the reason for this statement. Then we just solve the variable B by doing equation things here. By subtracting 48 from that side, we isolate B, and then we subtract 48 degrees from the other side as well, and that gives you that B's value, or size in this case, is 132 degrees. Example 2, we have clearly got angles about a point. This 48 degrees over here should actually just move a little bit in. I didn't see that before I put this document together, sorry people, but it's actually meant to be in this corner, in this angle over here. So the only missing angle that we have to solve around this point is the value A, or the size of A over here. And so we proceed by using the knowledge that we know that all these points together gives you 360 degrees. And that's the knowledge I write as my statement. So I write, and I'm going to try and fit it all in, A plus 40 degrees plus 40 degrees plus 68 degrees and 48 degrees is equal to 360 degrees altogether. The reason being angles about a point, abbreviated in that manner. Now we say that all of these are like terms, so on the left hand side I'm going to simplify by adding all of them together, and that gives me A plus 196 degrees is equal to 360 degrees. And then, see, I'd write no reason when I do solving of a certain variable by operations. There's no reason necessary then. Just when you start making that first statement, you write a reason together with that. Okay, anyway, so then we subtract 196 from each side to isolate the variable A. So minus 196. And that leaves us with A equal to 164 degrees. And there you have the answer to A. Okay. Right, guys, so you can move along to Spot on Mathematics, Activity 12.1, Question 1, and the worksheet exercise A. So I'll send a separate PDF document that contains all the exercises for the geometry going forward.